Hello, I welcome you to this particular video. We are going to be solving a video from the mechanics, engineering mechanics and dynamics, 14th edition by RC Hibbeler. This is engineering mechanics dynamics, 14th edition by RC Hibbeler. And in this question, I will not read everything. This you can read on your own. But we are being asked to determine the force of the rod and the normal force. This is what I'm interested at. The instant theta is equal to pi radians. Of course, they've given us the equations that governs the path, which is r. They've also given us the angle at which we are supposed to find this force, as well as the normal force. They've also given us the mass of the smooth cylinder, and by smooth it means there is not going to be any friction, no friction between, so there is no friction. We don't expect any friction between the path, this slotted path and the cylinder, and it's a vertical slotted path, therefore it means we are dealing with vertical plane. Okay, all right, let's draw the free body diagram. So let's say we do have, of course, we are dealing with the polar coordinates. So we do have one coordinate like so, which is the radial coordinate. This is the positive direction, and this one here is theta. So let's label them. This is r, this is theta. And then we do have the normal force. Let's say the normal force is somewhere there, tangent to that point. Let me use this color. Let me draw a tangent line at that point. Let's say that is a tangent line at that point. Oh, great. And then we do have the normal force, let's say at that point, like so. Okay, something like so. And then we have the weight. We do have the weight. Maybe the weight I should draw it. Let me put it down here. We put it down so that I can put the force on top. So this is our weight. And then we do have the force from this forked arm. So we have that force like so. So let's label this. This is W. This is F, and this is the normal force N. Okay. So we are going to have components. So let's say this here. This here is by this angle here. Okay, this angle here is my psi. Okay, so if that is the case, then so I have that angle there like so as my psi. Then this angle here will be my alpha. And if this is my alpha, this one is 90 minus alpha, therefore this is also my alpha. Does it make sense? Of course it does. It's supposed to make sense. So this one is also my alpha. Alright, so having established that, then we do have a component in this direction of the normal force and another one in this direction. Alright, so let's call this one here Okay, so this one here is just going to be equal to n sine alpha, and then this one is n cos alpha. Right. Okay, so there we go. Let's now start working out. Before we do so, let's also indicate the direction of our motion. These are the kinetic diagrams. That is my A arrow and that is my A theta. So our tan psi is just equal to r d theta, and our r, what is our r, is 0.6 theta. Therefore the r d theta will just be equal to 0.6. Therefore tan psi is just equal to 0.6 theta divided by 0.6. Okay, and we are evaluating this at theta equal to pi. Alright, and therefore our psi is just equal to tan inverse of pi. Okay, and this just gives us a 72.34 degrees. And this one is clockwise. Okay, so it's like so. It's clockwise, right? Not like that. It's like this. Okay, it's clockwise. Okay, and our alpha is just equal to 90 minus psi, which is 90 minus 72.34. Therefore our alpha will just be equal to 17.66 degrees. Right, so let's now work on the inputs that we're going to use for finding the acceleration in the r and theta direction. So we do have our r, which is 0.6 theta, and our r dot is just equal to 0.6 theta dot, and our theta double dot is just equal to 0.6 theta double dot. These are derivatives with respect to time. Alright, and our theta is just equal to pi. Therefore r at theta is equal to pi. This is just going to be equal to 0.6. Then before we continue with this, let's work out on what we have. I mean, we need theta dot. We don't have it here, but we do have our VC, which is just equal to this is equal to our V. This is equal to 2, which is equal to the square root. Okay, this is the resultant velocity, right, of Vr squared plus V theta squared. Okay, our Vr is just equal to r dot, and this is equal to 0.6 theta dot. Okay, and our V theta is just equal to r theta dot, and this is equal to 0.6 theta dot. Right. Yeah. So now from this we are able to find, so our VC therefore is just going to be equal to VC is equal to r point 6 theta, okay, squared. Okay, if this was also squared like this, plus 0.6 theta dot, and everything squared like so. Okay, so we are going to use this equation to find theta dot as well as to find theta double dot. So let's find this. Our VC is equal to 2. So this just becomes, if we were to make theta dot subject to the formula, theta itself subject to the formula, this just becomes equal to, theta squared. This is just going to be equal to, if we factored out theta squared from this, we'll have VC is equal to theta squared by 0.6 squared plus 0.6 theta, like so. Okay, then our theta itself just becomes equal to VC. Our theta dot itself just becomes VC, okay, squared divided by point is divided by point, okay, 0.6 squared plus 0.6 squared theta dot squared, like so. Then this is just going to be equal to, we know what this is, so we'll have a 4 there, 2 squared divided by 0.6 squared plus 0.6 squared, and then pi squared. This gives us 0.6 squared plus 0.6 by pi, okay, sorry, 0.6 squared by 0.6 squared by pi squared, then 4 divided by that. But this is supposed to be under a root, right? Sorry, I forgot a root here. This is supposed to be under a root. Okay, this is supposed to be under a root. Let me write a root properly. Maybe with this line. So this is supposed to be under a root. I almost forgot a root. Okay, so this is 0.6 squared plus 0.6 squared by pi squared, and 4 divided by that, and square root of that, and it gives us, once we do this calculation, then this gives us a 1.0110. all right, so now again we need to find the angular acceleration. So we said our VC is square root of BC just equal to 0.6 theta dot squared plus 0.6. Alright, so I can write down this. So this 0.6 squared theta dot squared plus 0.6 squared theta squared, and then we have theta dot squared. Okay, and VC we know is constant. Therefore, VC, V, the derivative of a constant with respect to time will just be equal to 0. Therefore, working out this with respect to time, we'll have 2 VC V dot like so. Then we have 0.6 squared. Then that will have 2 V dot, then V double dot like so. Then plus 0.6 squared. Here we are using product rule, so it's 2 theta dot. Okay, and this one remains constant like so. Then plus theta squared, and we'll have a 2 theta dot theta double dot like so. Okay, so this part becomes 0. Okay, therefore we'll have a 0 is equal to we found what theta dot is 0.6. We can work out this. So we know that our V, like we said, our theta dot, we calculated theta dot is equal to 1.0110. We can begin to replace that. So we'll have a 0 is equal to 0.6 squared times 2 times 1.0110. Okay, and this is just equal to 0.7279 theta double dot, and then plus we know that our theta is just equal to pi, so we can also work out this. So this just becomes 0.6 squared by 2 by pi by 1.0110. Okay, sorry, 0.6 squared by 2 by pi by 1.011 to the power 3. There are 3 of them there, right? So this just becomes a 2.3374. Okay, then plus there we have 0.6 squared by 2 by pi squared, okay, by 1.011. Okay, this just becomes a 7.1843 theta double dot. Alright, so making theta double dot subject to the formula from this, this just becomes equal to just 0.7279 plus 7.1843. Okay, and then we have 2.3374 divided by that, so this just gives us a minus 0.2954. So this is good enough. We found the angular acceleration and angular velocity. Now we can go ahead to work out these values. AR is equal to R double dot minus R theta dot, and this is just equal to R double dot. This one is equal to, did we work out what these values are? Okay, we didn't. Let's work them out quickly. So our our error at theta equal to pi. This is equal to 0.6 by pi. See, just 0.6, we can leave it like this. Then r dot at theta equal to pi. This is equal to 0.6 theta dot. What is our theta dot? We can multiply this. I think so. Okay. So this just becomes 0.06 like so. Okay, and then r double dot like so at theta equal to pi. This is just going to be equal to 0.6 by theta double dot is 0.2954. 0.2954. So this is minus 0.1772. Okay. And then with this information, we can now simply say our AR is just equal to R double dot minus our AR double dot minus R theta dot squared, and this is equal to minus 0.1772 minus R, which is 0.6 pi, and then theta dot, which is 1.011 squared. Therefore, our ARI is just equal to as minus 0.1772 minus 0.6 times pi times 1.011 squared. Okay. So we have a minus 2.1039. Alright, so R is positive, R double dot is negative. So A theta is just equal to R theta double dot plus 2 R dot theta dot. This is equal to, what is our R? Our R is 0.6 pi by R by theta double dot, which is minus 0.2954 plus 2 R dot. Our R dot is 0.66 like so by theta dot, which is 1.011. Therefore, A theta is just going to be equal to 0.6 times pi times minus 0.2954 and plus 2 times 0.6066, okay, which is our R dot, and then times 1.011. So this is 0.6697. So then let's apply the equations of equilibrium. We'll say summation of forces in the area equal to MAR, and then in the area we do have n cos alpha. Okay, n cos alpha is equal to MAR, and our n cos alpha, our alpha is 17.66 equal to our m is 0.4, and our AR, we found AR as minus 2.1039. Therefore, our n is just equal to 0.4 by 2.1039. Of course, this is a minus divided by cos 17.66. So this we get a 0.88 32 newtons. Okay, so it's 0.4 by 2.1039 divided by cos 17.66. Okay, 0.8832. Then we do have summation of forces in the theta direction equal to MA theta. In this direction we do have F plus W minus N sine alpha is equal to MA theta. Okay, so we have F minus mg, which is a 0.4 by 9.81 minus 0.8832 sine 17.66 equal to 0.4 by what is our A theta, 0.6697. Okay, so there we go. We do have that expression there. Therefore our F is just going to be equal to 0.4 by 0.6697, and then we have a minus 0.8832 sine 17.66, and then we do have plus 0.4 by 9.81. Okay, so F is equal to 3.92 newtons. All right. So this one, let me write this. Our n, this minus just simply means our n is equal to 0.8832 newtons, and it is going instead in this direction, and our F is going in that direction as calculated. So 0.4 by 0.6697, okay, minus 0.8832 sine 17.66 plus 0.4 by 9.81. Alright, I guess this is about it. We have calculated the value of n, which will be n instead is not in that direction. It will rather be going in that direction, like so. Okay, it's going in that direction like so. Okay, all right, so let's this is our value of n. This is the value of n, and this is the value of f. All right, I guess this is about it, and I hope this video was helpful. And if it was, give me a thumbs up, like the video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.